All right, Algebra 1x. So in your notebooks, this will be going on page 24, so go ahead and put a 24 on there. We're going to talk about the essential question when I come back and what you guys thought it was this time. So our next section is called solving literal equations. So we're still going to be solving and we're still going to be working backwards in our order of operations. But the problems are going to be a little bit more straightforward. Basically at this point what we're going to do is just work backwards in the order of operations. You won't have to worry about too much prep work. So getting rid of addition, subtraction, then multiplication, division, and exponents. So instead of solving for x, for instance, and having x equal -2 as the solution, what we're going to be doing is we're just going to be rewriting these equations so that instead of 7 equaling everything or 15 equaling everything, we're going to have y equal everything in pretty much most of these. So what I'm going to do is, since I'm solving for y, what I like to do is underline what I'm solving for because that's going to stay there, and I need to look at what I need to move. So in this first example, we're going to move 2x. So when I look at how 2x is connected to y, again, it's connected through over here in our order of operations, addition, subtraction. To get y by itself, I'm going to subtract 2x since 2x is added to y. And again, those cancel out because they subtract into 0, and then I'm going to come over to the right side of my line and do the same thing. So on the left side we still have y, but on the right side I can't take 7 and subtract 2x from it because they're not like terms. So I'm just going to write out that this is what I'd like to do and leave it like that. And you're done. You've solved for y. So again, instead of 7 equaling everything, I'm going to have y equal everything. And that is solving a literal equation. So let's try another one. Over here, I want to solve for y, so that means I need to move the 3x, and I also need to move this 5, and I want to look at how they're connected. So the 3x is being added to the 5y, and the 5 is being multiplied. So again, working backwards in the order of operations, what I want to move first is the addition subtraction. So I'm going to move the 3x first because it's been added. And when I do that, they cancel out, they become 0. Over here I'm going to subtract 3x. On the left side of my line I'm left with 5y, and on the right side I can't again subtract these because they're not like terms, so I'm just going to write down 15 minus 3x. So now what I want to move to get y by itself is the 5, and since the 5 is multiplied, to undo that, the inverse, I will divide by 5. So I'm going to divide this side by 5, and I'm going to take this whole side and divide it by 5. So those 5's cancel out. 5 divided by 5 is 1, and 1 times y is y. And over here is my answer. So this is a great answer, and for algebra, we are fine leaving our answer like this. When I see you guys again tomorrow, we'll talk about another way you could present this answer, but this is great. Okay? All right, let's try the one below it. So again, here I'm going to solve for y. When I look at what I need to move this -2x. And I need to move the 4. So typically we want to move our addition subtraction first, but you guys are probably not liking this problem very much because it's a fraction. So let's get rid of it being a fraction. And what's making it be a fraction is this dividing by 4. So to undo that division of 4, I'm going to multiply both sides by 4. And as we like to say, those 4's cancel out. And then I got to do the same thing over here. And on the left side, I'm still left with the -2x plus y. But on the right side, this is now 12. And now to get rid of the y, I'm going to move the -2x. And to undo a -2x being added, I'm going to add a +2x because those add up to 0. And then whatever I do to the left side, I'm going to do to the right side. And here we go. And again, we're not going to add those and make 14 or 14x because they're not like terms. We're just trying to rewrite the equation for different purposes, and we'll talk more about those purposes when I'm back on Thursday. So last one. This time we're not going to solve for y. We're going to solve for w. This is the formula for perimeter in a rectangle. And so to get w by itself, I need to move the 2l, and I need to move the 2. And again, I want to work backwards in that order of operations. So the first thing I'm going to move is anything that's being added or subtracted towards that w, and that's the 2l. So I'm going to subtract 2l. Those cancel out. Again, I can't make that into one term, so I'm just going to leave it as 2w, and then on the side I'll leave it as p minus 2l. And now to get the w by itself, I need to move the 2, and since these are being multiplied together, I'm going to undo it by division. So when I'm done, I have w equals p minus 2l over 2. And again, this is a great answer. And so now instead of everything equaling p for perimeter, I have a better equation, because what if they want me to find what the width is? And then this is a much easier equation to work with. So what I want you guys to try now is you try to solve for L. It's going to be very similar to what we just did. Okay, think about what you move, what needs to stay, and start moving those over there.